of suspension. And this time we have this software Lotus in front of us. This software is majorly used to design the geometry of the suspension. You can use various types of geometry, various types of suspension, both independent and dependent to design in this software. Mainly the suspension, this software is used in some of the MNCs, and also mostly used for the student projects these days, because we also have more advanced software to design suspension these days. Although this is the basic suspension designing software which we are using. So let us start our a little bit introduction to the software, and I'll be showing various geometries on this, and we'll try to explain you everything. So before getting into the software, there is in steps which we have to do with this software. So basically, suppose if you are designing a suspension and you're designing a double wishbone. So what all you will get from this software is the length of the wishbones, the angle of the wishbones, the geometry, the overall geometry, like what should be the sizing and everything of the wishbone will be getting from this software. So what is the process? Basically, the process is to understand the design first, and then when you finalize the design in this software, in this workspace, then you will import all those data to 3D CAD modeling software and CAD model all the components which are there in the suspension. So if you'll see what are the components majorly we get in the suspension is the A-arms, the shock absorbers, the dampers, the knuckle, hub, tie rods. All these are the connections to the tire, and we have to get the sizings, inclinations, and overall geometry of these components to be projected in our design. And the same thing, when you finalize everything in conjunction with all other things, then what you have to do is you have to export all these points, all these dimensions to an 3D CAD modeling software. Either it could be SolidWorks, CATIA, or any other like Autodesk or Creo, any other software for 3D CAD modeling, and then you can start making or giving it a shape. The geometry is the part which you will get from this software, which is more desirable and easy to project. So what exactly we do in this software? Let us start our brief introduction to this software. So you have all the command tools on your left. There will be always four, columns and the rows which you will have on the left, which controls the overall geometry on the task space. Okay. Suppose if you don't have all these four, options here, what you have to do? You have to go to setup, and you have to make all these four toolbars visible. As you can see that there is a blue tick in front of all these four options, right? So it has to be there in your PC as well as when you are setting it up. So these are the options which should be always activated so that you have all the commands on your left. Okay, and then we always have the software default command on the top. So the next thing which we have to do over here is suppose I'll tell you what is the options and how do we take. So we should always start with like other software, we should start with a new file. Okay, when you click on new, the software will generate a window in front of you. So you have to pick up few of the options in this window to generate your first model. So suppose if I am designing a front suspension, so you can find there are various geometries in this suspension system, right? So I'll explain you one by one. So we have double wishbone, damper to lower wishbone. Suppose the tire is connected with two of the wishbones and damper is installed in lower wishbone. If you're going with this kind of configuration, then you have to choose the type 1. Basically, that type 1 is majorly observed in the front as suspension, and type 6 will be majorly observed in the rear of the suspension, because the damper and the shock absorber is mounted on the upper wishbone, because we need space for drive shafts to go in when there is an rear wheel drive. In case of front wheel drive, you'll find all these dampers installed on the upper wishbone. So wherever you drive, you will have to choose your suspension. Steerable McPherson strut is for all the hatchback category cars or the commercial cars which we have in market, which all have the front line drive, and it is connected with the McPherson strut. McPherson strut is basically the shock absorber, but this is made for heavy duty purpose. Then we have various other arrangements for different performance targeting of the vehicle. So you can study about all these things by your own. And in our vehicle dynamics classes and suspension also, we have tried to cover most of the part of this. So what is a front suspension? Suppose if I am choosing a double wishbone damper to lower vision, this is the type of suspension which I have chosen. Okay. Next thing is whether I have steering box or steering rack. Steering box is basically the steering type which is driven by the gears, and like suppose the pitman arms and the tractor gearbox and all those things. But steering rack is something which you will find in all of your cars. So suppose you select steering rack, and I'm not designing the rear suspension now because I'm just taking an example to display or give you the introduction about the software. Now we have three more things which has to be done, which is edit parameter data, edit tire data, and set units. So these are the three things which we have to fill before we generate our model. Okay. So suppose we fill various, the software has to understand what kind of geometry we want. So for that it needs few predetermined data, which is bump travel, that how much is the tire allowed to move when it goes under bump. With the same with the rebound, opposite of the bump. Rebound and bump increment. Okay, what is the tolerance value you want to set for this increment? Roll angle, steer travel, steer increment. So all these values you have to feed according to your design and click OK. Same goes with the tire data. Like you have to fill the radius, tire width, and other properties of the tire which you get from the tire data book. If you don't have, set it as default and apply OK. So units is always in mm and Newton. So the same thing is applied, so no problem. Press OK. When you fill all this data and press done, then software generates a model for you. Okay, this is a model which is generated by the software for your suspension. So this is the front view. Let me tell you all the nomenclature of this first before getting into the design, or what should we do with this suspension if we choose particular car for designing our suspension. So we should be in the condition to understand every point which is displayed in this free body or the geometry diagram. Okay, so first of all, why we are getting all these so many yellow lines on our left and right, and why the tires also having a lot of images, same with the suspension. So let me tell you that when we were designing, when we are putting up the values over here in this data sheet, then we have entered a bump travel of 60 mm. Means what? These yellow lines shows you that how the tire or how the other components of the suspension will be positioning itself when it is traveling to all those distances. So it is trying to show you the all the boundary distances and what should be the condition of the tire when it is traveling to this. So if you will see on the left, like if I zoom it, then you will see that the tire is not straight at all the points. It is having some angle, it is gaining some angle when it is traveling up, and then again it is gaining some other angle on the other direction when it is going down. So obviously as a design engineer, you don't want the tires to behave like this. You want the tire to go up and down straight. It should not turn, so that the tire life increases. So all those stuffs we will come to understand when we'll start designing the geometry. Before that, these are the figures which you will get when you will enter the data at first. So how do we, first the basic thing is how do we pan this diagram and how do we zoom in, right? So first thing which you have to see in this is the second row, you'll find this palm option, right? Your hand option. So with this hand option, you can pan your CAD design, design I'm saying, yeah. So this is the way you pan with your left click from the mouse. You have to hold the left button of your mouse and move it. This is how you pan. Then zoom. Zoom is just below the pan. If you click on this, and then when you zoom it, see, you have to click left button of your mouse and drag it up. If you're dragging it up, the zoom out is coming. When you drag you have to press the button. You have to hold the left button of your mouse and drag your mouse down, then you are zooming in. So this is how you zoom in and zoom out. Okay. Next option is the rotate. So suppose if I want to rotate this diagram and I want to see the 3D geometry. So this is how you rotate. Again, the left mouse and you rotate. Click on the rotate option from here and then you can rotate your design, right? So you can see the location and everything of your design. Now suppose if you have rotated and now you again want to come back to the ideal image. So you have all these ZY, ZX and XY locations or options over here. So suppose if I go with ZY, ZY is the front view, ZX is the side view and XY is the top view. So you can anytime choose between all these options to see the design. Okay. So the next thing would be how do you want to see your tire, and whether you want to see the edges or you want to see the body and all those things you can do. This is only for the visibility purpose, so it's better to don't get into it. Next thing would be to explain you what are all these components. So suppose before that I don't want to see the every position of the tire at every bump. So I just want the tire to show me the geometry, or the system to show me the geometry when the vehicle is at static state, when it is not moving at all. So what you have to do is go to view command, then you have to go to screen display and press on single step. This when you want the software only to show you only the position at the static state. So press single step and the software will show you the position of the tire when it is in touch with the ground and not moving. Okay, so it's better that we are getting only one position. Now it will be very clear to understand what nomenclatures are there in this picture. So I'll zoom in, okay, and you will find out that every point or every nodes in this design is numbered as 1, 2, 3, 4. You will find it that way. Okay, let me explain you all the points. So 16 to 17 is your spring, 9 to 8 is your damper, 5, 6, 7 is your upper wishbone, 1, 2, 3 is your lower wishbone, 11 to 12 is your tie rod, 7 to 3 is your knuckle, 3 to 18 is your 11 to 18 is your steering arm, and 18 to 19 is your spindle axis. Let me tell you again for memorizing purpose. It's very important and you must all know about this. So again, 11 to 12 is your tie rod, 11 to 18 is your steering arm, 18 to 19 is your spindle axis, 7 to 3 is your knuckle, 5, 6, 7 represents your upper wishbone, 1, 2, 3 represents your lower wishbone, 8 to 9 represents the damper, and 16 to 17 represents the suspension system. Shock absorber. So this is all you have to geometry to get a perfect suspension. And also two more important thing is the blue dot over here represents the roll center, and this represents the center of gravity of the vehicle. These are the two most important things which we have to understand design the geometry. So this is something which you have to know for now, and I would like you all to go back, rewind the video, and again go through the video so that you can understand the points very well. Next thing is we will be moving forward and we'll see what the software gives. Suppose when we enter the data about our design, this software automatically generated a model in front of us, right? So what is this model? Is this model right for us? Is this model wrong for us? Or we should use this model directly to design the suspension or CAD modeling or not? So these are the all questions which we will come to know in our next phase. Okay, so now after suppose that I have finalized that this is the model which I have to use for my car and I have to CAD model. What is the next thing I have to do? The next thing I have to do is I have to simulate this model. So you'll find that simulation option over here. See, this animation, this command shows you the animation or simulation. Okay, so you are simulating your motion, simulating your diagram or your design to see whether how is the flow, how is the spring compressing, how is the damper compressing, how is the tire in conjunction with arms is moving, how is the tie rod moving, and how does the roll center behaves in front of center of gravity. So suppose this is the motion which you are getting. Ideally, this is an ideal motion. Generally, this doesn't happen because the surface line which you will see is moving up. Generally, this motion is not a real motion. So suppose if I have to generate a real motion, then I have to change the reference. Suppose here, if you will see, change to ground plane motion, and this one is change to body motion. We have to get to the change to body motion, which shows us the realistic motion. So in real case, the tire never moves up and down, or the it never loses a traction between surface and the road. Only the body part is overall body of the vehicle is moving. The center of gravity is moving. Roll center is moving. Your suspension is moving. The arms is moving as shown in this picture. So this is the realistic model of the car, and this is how the suspension will be behaving. The most important thing which we have to notice over here is about the tire. How is the tire moving when all this motion is happening? So what are the things to notice when this is happening is, so first thing is whether the tire gaining some angle, whether it is tilting in and out, or how much it is laterally moving or rubbing to the surface when the overall suspension is going up and down. What is that distance, whether we can reduce that distance or not, because if that distance increases, the slippage will increase and the Ackermann geometry will be more difficult to calculate if the slip angles are more. So there are many things which we can observe from this simulation, and then after observing all those things, then we have to correct that thing by setting up the relations between all these things, right? So all of these things, all of these links which are joined with the tire or connected with the tire is moving in relation with each other. So we have to set a relation between them so that we get a desired result which we want. So obviously we have to customize the design and we have to bring to our case. So this is the simulations which you have to do and see whether your overall geometry is fine or not. What is the next thing? Suppose if I have finalized this design and this design is all set to go for final observation, what you have to do is, the next thing is you have to generate the graph. So this is the option over here on the top. You'll find this option to generate the graph. If you click it one time, you will get the camber graph, right? Again, if you click it, you will get the toe angle graph. I believe you all know about the camber, toe and caster. So again, if you'll click, you'll get the caster graph. So you'll get the three basic geometry performance curves directly from this software, and you'll come to know how is your tire gaining angles during all these motion. One thing you have to do is right click on each of the graph and auto scale this for more clear view of the angles. So if I have to read this graphs which is generated, you will find that when this tire is going in a drop, means when it is traveling down to 72 mm, the tire is gaining a positive camber of 0.756, which is very less. And again, when it is traveling up, it is gaining a negative, means negative camber of minus 1.654, which is again considerable. So anything between 1 degree or 0 degree is considerable, because you can never reach to 0, because you also have to see to the other things like toe angle and caster, that also has to be controlled. So if you change the toe, obviously automatically the camber will change and the caster will change. So you have to make sure that you create a balance between all these three graphs to generate your model properly. So talking about the toe angle graph, you'll find that again this all is happening in conjecture with the tire moving up and down, and we are seeing like how the camber, how the toe and how the caster of the vehicle is changing. So you can read the other graphs also similarly by this way. Again, if you keep on clicking, you'll get various design features, design geometries of your vehicle, like kingpin inclination, damper, spring, anti-dive, anti-swerve, half track. You can find every dynamic character of your vehicle from this software directly, which is very difficult to calculate using the formulas, or which is very difficult to calculate if we don't have the softwares like Lotus with us. So this is our important thing. After the final observation from the graph that our design is okay, what should we do next? Always remember to delete these graphs. Now, next thing is that once my design is final, I have observed everything. The next thing is to check the 3D coordinates of all my points. So you have to click on this SDF command folder here, and it will generate a window in front of you which gives you the 3D location of all the points which are there in your system. So suppose if you will zoom in, so point number one, which is lower wishbone front pivot. So lower wishbone front pivot is which one? This here, okay, here in front of point 2, point 1 will be here behind point 12. So the 3D location of that is given, means XYZ coordinate of that thing is given to us. Then lower wishbone rear pivot point, three coordinates, means for all 16 to 19 points which is listed in this diagram, we get the 3D coordinate of all the points from here. Since this is our design and a final model, we have to put all these points, or we have to take the 3D coordinate or help of all these dimensions to CAD model our software, CAD model our components, right? So suppose if I have to design the front or upper wishbone, then we have to take point number 5, 6, 7 in the same model. We have to take it in the same model and then give it a shape which is desired or to manufacture. So this only gives me the location of the points, right? So we have the XYZ coordinate. How do we do it next? So what you have to do next is you have to open your SolidWorks, and then you have to go into a 3D sketch and take all these 3 points and give them their dimensions, and then you give them the shape. So I'll tell you how to do that. Open part in your SolidWorks, then go to 3D sketch. So you have to drop down from sketch and choose 3D sketch. In 3D sketch you choose the point. So suppose I've chosen a point. So click anywhere on this space. You have defined your point. Then the software will ask you XYZ location of that particular point. So this XYZ location will come from here. So your upper wishbone front pivot is 4092 mm. So first thing is x-axis 4092 mm. Don't forget to write mm at the end. Then 420 in y. Y is 420 mm. Then z is 452 mm. So this is how you enter or define the point. Once you enter that, press OK, and then click on this zoom to fit so that the point is located to you. So this is the position of the point which you have drawn in the Lotus. So this is the first point. Now we have to take another point. So one more time, and then again you have to define this point. So next thing is 4332 mm. I'm defining the sixth point over here, which is 4332 mm. So go into your software, 4332 mm. This is X. Then again Y is 420 mm. Then again 446 mm. 446 mm. So you have defined your next point, which is over here. Again you have to take one more point, which is the last point, which is 4092 mm. So you have, what you are doing is simply taking the data from your Lotus and entering into this 4092 mm, then 695 mm, and the last is 454 mm. Right. So we have defined our third point also in this, and then you can zoom to fit to locate where your points are. So this is my 3 points, and then what you have to do is we have to, in the sketch, go to feature, go to reference geometry, select on plane, and take the plane which is connecting all these 3 points. So suppose this is the plane which we wanted. Make it perpendicular to your view, and then what you have to do, you have to sketch on this plane. Okay, so you have to connect the planes with a line. So suppose I will connect this and this, and this is the arm. This is my arm which I have generated from SolidWorks, which follows the geometry of what we want. Again, what I want to say with this is, since I joined it simply straight, I have joined the lines and I've taken the lines and simply connected all these 2 points. You can give it a different shape as well. The only thing which you have to take care is that the points are not moved from the locations which are. So I can give different shapes to my wishbone, whatever I want, but the only thing I want is not to move the points from its state, because this gives the geometry, this follows the geometry. So I can give any shape I want, but only thing is the geometry should not be changed. The location of the point must not be changed, because the location decides the geometry and shape decides that what amount of forces the wishbone will be able to take. Okay, so suppose if the wishbone are able to take all those load, if it is simply connected, I recommend people to go with the simple design. If suppose it is not able to take that and you are further optimizing your design on dependent upon the shape of the AM, then obviously you can have different variety of shapes which are there. The only recommended thing is you don't move the point, right? So this is how you take all other points and you make your part. So we have made upper wishbone. Now you have to make lower wishbone with these 3 points, right? Then what you do, you can find the distance of 7 and 3 to find the overall size of the knuckles, which you can obviously take from the diagram. So this is how we work in this software, and this is how you have to work and you have to practice in your software. uh, the next part or the next phase would be about we'll be taking a realistic example of the suspension system, and then we will modifying the lines, modifying the design to adjust the camber and caster, which was not covered in this video. So this is only the introduction part of this software. In our next stage, we will be taking a live example of any car and we'll be designing the overall suspension in the Lotus.